Overview 1.07 Geometry Triangle Proportionality Theorem 2. In this video, we are going to prove the angle bisector theorem, the Pythagorean theorem using triangle similarity, and solve problems using the angle bisector theorem as well as the Pythagorean theorem. An angle bisector of a triangle creates a proportional relationship within a triangle. So we notice that the triangle angle bisector theorem says that a segment that bisects the angle of a triangle divides the opposite side into two segments. I've gone ahead and highlighted that in green. The segments are proportional to the other two sides. So here, BD bisects angle ABC in triangle ABC, which results in the proportion AD divided by CD is equal to AB divided by CB. The other equivalent proportions can be generated from the relationship using the properties of proportion. For example, AB divided by AD is equal to CB divided by CD can also be used to solve problems. Given AB is equal to 3, AD is equal to X, and CD is equal to 8, CB equal to 12, we can solve for X. We would identify the proportion AD divided by CD equals AB divided by CB. Substitute the known values, and then cross multiply to solve for X. 12x is equal to 24. 24 divided by 12 is equal to 2. Therefore, x is equal to 2. We can check our work by plugging 2 in for x or substituting x for 2. And we get 2 divided by 8 is equal to 3 divided by 12. Cross multiply, and both of them equal 24. The converse of the triangle angle bisector theorem says if a ray or segment divides the opposite side of a triangle into segments proportional to the other two sides, then the ray or segment bisects an angle of the triangle. In other words, if AD divided by CD is equal to AB divided by CB, then BD bisects angle ABC. The segments form the proportion 5 divided by 10 is equal to 7 divided by 14. To prove whether BD is an angle bisector, you can either reduce each ratio in the proportion, which would be 1 over 2 is equal to 1 over 2, or cross multiply to get 70 is equal to 70. In conclusion, BD bisects angle ABC. Now let's go ahead and look at this problem. What is the length of CD? We notice here that they've plugged in X for CD, and they've given us the other measurements for each line segment. We can identify the proportion as AD divided by CD is equal to AB divided by CB. We'll use the angle bisector theorem to set this up. Substitute the known values. 10 divided by x is equal to 15 divided by 18. Cross multiply so that we get 15x is equal to 180. Divide both sides by 15, and we find that x is equal to 12, which answers the question, what is the length of CD? CD is the measure of x, therefore CD is equal to 12. Here we're going to go ahead and solve for x. We notice that we have triangle ABC, and we have two different x's in here on two line segments. So the first thing that we're going to do is use the triangle angle bisector theorem to set up the proportion. We're going to substitute the values for each segment. And then we're going to use the means extreme property to cross multiply. Here we have AD divided by CD is equal to AB divided by CB. When we substitute the values, we substitute x divided by 10 minus x and 6 divided by 9. We can cross multiply and we get 9x is equal to 6 times 10 minus x. Make sure that we distribute 6 to both 10 and negative x, which will give us 9x is equal to 60 minus 6x. Solving for x, we need to go ahead and add 6x to both sides, which gives us 15x is equal to 60. Then divide both sides by 15, and we find that x is equal to 4. Therefore, AD is equal to 4, and DC is equal to 6, because 10 minus 4 is 6. To check your work, set up your proportions, substituting x for 4, and you find that by cross multiplying, both proportions are equal to 36. Next, we're going to determine if BD bisects angle ABC. So we see that each of our sides has measurements. So let's set up the proportion so that AD divided by CD is equal to AB divided by CB. We're going to substitute those for 9 divided by 21 is equal to 6 divided by 14. And then we're going to cross multiply. Now, since both of these are here, we have the measurements here, then we can actually just simplify. If I simplify 9 divided by 21, I get 3/7. And if I simplify 6 divided by 14, I get 3/7. That's another way to prove that BD bisects angle ABC. If you have any questions about this lesson, please feel free to contact me via text or email.